Welcome to part 3 of the lecture about homogeneous systems of equations. So let's turn to this example. We have a matrix with 3 rows and 5 columns, and if we want to consider the calculation of the null space, that is analogous to computing the solution set of a homogeneous system of equations, and that would be the system that has this matrix as the matrix of coefficients, right? So this matrix of coefficients would be considered this matrix, and the vector of constants is the vector of zeros, and so to find the solution of that homogeneous system, we would row reduce the matrix, and that is exactly what we do to then write the null space. To compute the null space of a matrix is no other thing than computing the solution set of this homogeneous system of equations. So in this case, we have m equals 3. We have 3 rows, and we have 5 columns, right? So here the number of columns is 5, and by computing the RREF of this matrix, we find out that little r equals 3. The number of columns and r do not match, and therefore this is a scenario in which the solution set is going to have infinitely many solutions, right? In particular, there are indices of variables when considering this as variables of a homogeneous system that are considered dependent variables. So here we have index 1, index 2, and then index 4, okay? And then the indices on the set capital F will contain 3, 5, and 6. One thing to observe here is that the number of columns in the original matrix is 5, n equals 5. And this RREF is the RREF of the augmented matrix, right? So in terms of indices, this index 6 doesn't correspond to the index of a variable. Variables are only having indices 1 through 5, and of those indices we're interested on 1, 2, and 4 as indices of dependent variables. So for example, the first row, I always do the first row, so let me just do in this example the last one. You should do row 1 and 2, but from the last row we read that you have 0 x1 plus 0 x2 plus 0 x3 plus 1 x4 plus 2 x5, and this equals 0, which means that from here it's straightforward to solve for x4, and x4 equals minus 2 x5, right? And so you would do the same to solve for x1 and solve for x2 in terms of x3 and x5, and that leads to the following. Leads to the following expressions, right? Doing this type of calculations, we would have an expression for x1 in terms of x3 and x5, another expression for x2, and the expression we just computed. So we can write the solution set in this form, where we don't write x1, we write this expression for the first entry. This other expression is going to substitute entry number 2, and entry number 4, x4, will be expressed as minus 2x5. And then we write the vertical bar, and after the bar we specify which are the so-called free variables. So this is a solution set, okay? This is a solution set, but it's also that solution set this is the solution set of the linear system with matrix A as matrix of coefficients and vector 0 as 0 vector as the vector of constants. That solution set is precisely what we denominate the null space. So this would be called the null space of the matrix A, n of A. Now, here's another example. We have a matrix that has this matrix has m equals 4 rows, and n equals 3. Okay, and we augment the matrix and with a column of zeros and row reduce, and then in this case, remember here we had established that n is the number of columns, number of variables, and this linear system of equations with this as being the coefficient matrix, there would be 3 variables. But also we find that the number of non-zero rows of this RREF equals 3. So n and r are exactly the same, and then we would conclude that in this case um, there is only one unique solution. So one of the things we would conclude from here is that x1 equals 0, x2 equals 0, and x3 equals 0. So the solution set of this linear system with the 0 vector as the vector of constants, that solution set contains one element and one element only, which is the trivial solution. Okay, so in this case, um, we would say that the trivial solution is the only element of the solution set, and in fact, the trivial solution is the only element of the null space.